This problem deals with the rates and times for gas effusion. Specifically, we are told how long it takes for a certain amount of helium to effuse, and we're asked for the time that it would take for the same amount of ethane to effuse. The rates of gaseous effusion and the times of effusion are controlled by Graham's law, and in its simplest sense, Graham's law says that in terms of the time taken is proportional to the square root of the molecular weight of the gas, helium in this case. The way we usually see Graham's law used is in terms of a ratio. So in this case, since we have helium and C2H6, and we're given the time for the helium to effuse, and we're asked for the time for the C2H6 ethane to effuse, and we should set up the ratio this way. T C2H6 over T of helium will be equal to the square root of the molecular weight of C2H6 divided by the square root of the molecular weight of helium, atomic weight of helium in this case. Now notice that since we're talking about time increases as the molar mass gets larger. Big molecules effuse more slowly than little molecules. So we can now solve this thing for the time of C2H6 effusion. T C2H6 will be equal to T of helium times the square root of the molar mass of C2H6 divided by the square root of the molar mass or atomic mass of helium. So this will be 1.25 minutes times the square root of the molar mass of helium, which is a little over 30, divided by the square root of the molar mass of helium, which is just a little over 4. So this will be 1.25 times approximately 5.48 is the square root of 30 divided by 2.0, and that gives us 3.42 minutes for effusion of C2H6. Now remember, this problem was in terms of the times. The rates of effusion are inversely proportional to the molar mass should you come upon a problem that talks about how the rate of diffusion of two gases compares.